Hey friends, what we're going to do in this video is we are going to go over the greenhouse effect. So make sure at the top of your page we're putting in that title. Greenhouse effect. All right, then we're going to turn our paper like so, like that. Okay. All right, my first thing that we're gonna do is we are going to use this top left corner to put in the steps of how the greenhouse effect works, and then we're gonna put a diagram starting here that kind of builds up this way. So the first thing we're gonna do is we're gonna draw in our Earth, because obviously we need an Earth. Okay, Earth. And then we're gonna throw some land on it, otherwise it just doesn't feel right. Okay, now we are only gonna focus on 2 layers in this diagram. Okay, we have this first layer. Let me zoom you in just a little bit so you can see better. We have this first layer, the first layer of the atmosphere closest to Earth, which is called the troposphere. Okay, troposphere. And then the second layer, which we know is the stratosphere. So troposphere and stratosphere. Inside the stratosphere, we have this layer. This layer is called the ozone layer. We now know that ozone is a greenhouse gas, and we have some background information on what greenhouse gases do. So ozone, this greenhouse gas, O3, is responsible for trapping heat. So I'm gonna put O3 so that repetition is life, so that we have that little bit of memory. And when we say O3, we mean that there are 3 oxygen atoms bonded together. The gas that we breathe is O2, oxygen. That's the gas that we breathe and our bodies use for respiration. O2 would be 2 oxygen molecules. Now, it's important to note that ozone is considered a ground level pollutant. It is really nice up here in the stratosphere, but ozone formed at the ground of the troposphere is not good for human health. All right, now, the next part of this is we need a sun. Our sun, way out here. Okay, this is the sun. And we know that that sunlight shines. Okay, we have some of these sun rays shining down. All of this electromagnetic light. Okay, this is incoming radiation. So in here we're gonna write incoming radiation. Incoming radiation. And that's exactly what that means. Incoming means that it is moving into our area. It is incoming radiation. Now, this radiation has a couple different paths. That's where our process begins. Step 1. Radiation from sun moves through space and reaches Earth. / Earth's atmo. Okay, so here's that incoming sunlight. And we know atmo is short for atmosphere. that incoming radiation reaches Earth's atmosphere. Some of that sunlight is reflected back. Some of it hits the outer layers of the atmosphere. Some of it hits that ozone layer. Some of it gets to Earth. Some of it gets to Earth. Okay? This is step 2. So this is step, so maybe we should number. Here's number 1. Okay, here's number 2. Sunlight comes in. Sunlight hits Earth, that's number 2. So conduction transfers sunlight into heat. That rises in our atmosphere. Okay, so here's 2. Step 2 is conduction. Conduction, you have that sunlight changing into heat, into infrared radiation. That infrared radiation begins to rise. Okay? Sunlight, conduction. Conduction changes that into heat. Because remember, when we think about our electromagnetic spectrum from last year, electromagnetic spectrum, we had infrared radiation, we had visible light, we had ultraviolet radiation, all right next to each other. Okay? All right, now this is step 3. So this part right here, this is step 3. Step 3 says greenhouse gases in the ozone layer trap some of the rising heat. So we have sunlight changing to heat, heat rises. That ozone layer, those greenhouse gases, trap some of that heat. So when they say trap, we mean that rises, it gets trapped, and it gets blocked, and it gets sent back down. This is where it starts to warm again, and it rises, gets trapped, gets sent back down. Okay, when it gets trapped, what sends it back down? It's the fact that when it gets trapped, it cools and then it sinks. So we have warming, rising, cooling, sinking. That should ring a bell. Warming, rising, cooling, sinking. Okay, and this happens all throughout the troposphere. Okay, also the next thing I want you to notice is I've made these wavy just to differentiate that we have 2 different types of radiation. Both of these wavelengths are radiation. This one is infrared radiation, heat. This one is visible light, which in that electromagnetic spectrum is that visible light. Some of it's ultraviolet radiation. But it's important to note that this right here is not heat. This is not infrared. This is ultraviolet, and this is visible light. And that visible light and that ultraviolet light comes down, hits Earth, touch, conduct, and then gets trapped. Now, the key word here is some. This is how Earth is different from Venus. Venus has an ozone layer. Venus has greenhouse gases in its atmosphere that is way too abundant. There's too much of it. So not enough of that heat escapes. Some of this heat does escape. And that's a good thing. If we kept all of this heat trapped, if we trapped all that heat, we would be like Venus. It would be too hot to survive. Okay? So this area right here, this is called outgoing radiation. Okay, we have incoming, outgoing. All right, now this right here, this part right here, we're gonna label this area 4. This is step 4. Okay, now step 4 is this trapping of heat creates convection. Okay, there's convection. These are your convection cells. Take a good note of where they're, oh, we can do it over here too. Boom, okay. All along the troposphere where we live, we have convection. And remember, convection is warm air rising, cooling, sinking, replacing. Rising, cooling, sinking, replacing. And that replacing part is where it's warming. Warming, rising, cooling, sinking. So you know me, I'm a stickler about these arrows. Warming, rising, cooling, sinking. There's convection. Convect, right? Remember from our vocabulary, convection. Okay, and then our final step, step 5. This is just kind of like our summary statement. This is kind of the whole reason. Why is it important? We're gonna put a big old star next to number 5. Number 5 is the whole thing. So this convection, and this is why we stopped and we did this before we're moving into global winds and climate and weather, because all of this really kind of dictates that. This convection and transfer of heat is regulated by the ozone layer. Comma, which then regulates regulates is another word that kind of means to control. Like the thermostat regulates the temperature in the house. The thermostat regulates the temperature in the classroom. When you set that thermostat, it controls how cold or how warm that area is getting. Okay. Regulates Earth's global temp. This global temp we're going to eventually know as climate. Okay? All right. Troposphere, stratosphere, ozone layer, ozone made up of O3. There's also other greenhouse gases in here. So you could put that the ozone layer is predominantly made of ozone. However, there are other gases in this layer. Okay? So at this point, if you would like, I think it might be beneficial if you would like to add some color and to note that this area right here, this is heat, this is hotter. We have our incoming sunlight. Okay, here's incoming radiation. And then outgoing radiation is a combination of heat and some of that ultraviolet light that doesn't make its way in. We have our Earth. And then the next thing I might do is to make sure that you know where your, what color should I use? Let's use purple. I'm gonna use purple. Where your numbers are. So this is number 1, okay? And I'm just gonna color code like just these numbers. Here's number 2, okay? Here's number 3. Here's number 4, just so you can easier find your information. And then 5 is the whole, it's the whole reason. 5 is the whole purpose. What was the reason? 5 was the reason. Okay. All right. Don't forget your page number and don't forget to update your table of contents. This is our quick sketch notes for greenhouse effect.